Alright, so we have a problem here. It says how many atoms are in 3.50 grams of gold. And the first thing we want to do is kind of determine what are we going to need to do a problem like this. Well, I see the word atoms. Atoms is a type of particle, so I know I'm going to need to use Avogadro's number here. And I also see mass. Well, mass means usually I'm going to have to use molar mass at some point. So I need to write some conversion factors that will help me out to complete the problem. So I know that 1 mole of gold has this many atoms of gold, Avogadro's number, 6.02 times 10 to the 23rd atoms. And I also know, when I look on the periodic table, that 1 mole of gold, the molar mass of gold, is 196.97 grams. And these are all equal. You know, we kind of say if A equals B equals C, I can use any of those three in any combination if I'm doing the conversion for it. So I'm going to say, set up my bracket system. How many atoms of gold are equal to, my given number was the 3.50 grams, of gold. Go ahead and put the symbol. We set up our bracket system, our conversions. Grams of gold, excuse me, and I want to go to atoms. So I need a conversion between grams of gold and atoms of gold. And again, if A equals B equals C, well, it's true that B and C can be used in a conversion factor. There's atoms, there's grams, there's atoms, so I can just plug in those values into my conversion factor. In 196.97 grams of gold, I have 6.02 times 10 to the 23rd atoms of gold. My grams cancel. And this is a situation where we do not have a 1 in either our numerator or our denominator. So this is a problem that we're going to have to multiply across the top and then divide by 196.97. So when I do that, 3.5 times Avogadro's number divided by 196.97, I end up with 1.07 times 10 to the 22nd atoms of gold. And there's our answer. Now, why did I round to 3 sig figs? Well, I have 3 sig figs here, I have 3 sig figs here, I have 5 here, and as always, we go with the least amount when we're multiplying and dividing. So 1.07 is 3 sig figs. Now, does the answer make sense? I always want you to look at that before you move on to another problem. Well, to have 1 mole of gold, I need 196.97 grams. I have 3.5 grams of it. I don't have any grams compared to the molar mass. So I would expect my answer to be smaller than Avogadro's number. And of course, 10 to the 22nd and 10 to the 23rd, certainly 10 to the 22nd is a smaller exponent. So the answer looks right, 1.07 times 10 to the 22nd. And that's how you do a standard mass to particle problem, or grams to particle problem.